Welcome here. If that camera can be steady because it's doing a bobblehead there. Now, first you'll notice, why am I wearing a Batman shirt? Because it's Halloween this week and bats are scary. I know, I'm very scary right now. Grade 7s, we're doing 3.5 dividing decimals. But first we're going to take a look at our concept from last week, which was multiplying decimals. And we used this model. I'll just pause for those of you who are drawing at their show me boards. I want to make sure that you are with us. Thank you. So last week we looked at how we could use base 10 blocks and do a block method for multiplying decimals. Here's an example, and maybe you can zoom in on this, Mr. Camera Guy. 1 decimal 8 times 0.4. So what we did is we went 1 block wide plus the decimal 8, and then we have decimal 4. This is just like back in the day when you would have, say, a rectangle that was 3 times 2. You could just multiply it. But now we're doing a rectangle with all these little rectangles in the middle. We have 1 decimal 1, 2, 3, 4, 5, 6, 7, 8, and then times decimal 1, 2, 3, 4. And when we put that all together, we can see if we counted all these together, there's 10, 20, 30, 40 of those little hundredths. And if you look here, you'll have 8 times 4, that's 32 hundredths more for a total of 72 hundredths. But what we're going to do now is we're going to flip it on its head. We're actually going to use some of our models to divide. So I'm going to scroll down, we'll take a look. Now this is where you're watching the video and you go, Mr. Ewert, those numbers are too small, I can't quite see them. Well, that's okay, because if you're watching this video, you should be in my class, which means you have a copy of this textbook with you as you watch it. But now let's take a look at an example first. And I want to see those of you on your show me boards if you can do this just with your numbers. Jan bought 2.8 meters of framing to make picture frames. Now each frame takes 0.8 meters. So what that means, and Mr. Camera Guy, if you can widen it up so you can see my board here. She buys this framing and she bought 2.8 meters of it all the way to the end like this. Now we know that each frame takes 0.8 meters. And we want to figure out how many frames can she make with it. So this is how many frames can Jan make, how much framing material is left over. So we've got 2.8 divided into 0.8. So we want to figure out how many of those can we put in. So we've got 2 decimal 8 divided by 8. All right, I'd like you to pause the video. We're going to work this out on some show me boards. We're going to come back and see.
I'm back at it again.
Welcome back. Can you just pause the video? Or yeah, it's doing the bob. All right. I thought it was really fascinating. About half of you started going to pictures, and half of you went to the symbols, and that's fascinating to me. I like seeing it. So first, I'm going to pretend that this is like last week. I'm going to go 2.8 times decimal 8. Okay, so I've got 1, 2.8. And then I'm going to go times decimal 8. Well, that's where, let's split these because we know that each one of these would have been 10 rows and 10 columns, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now what you're seeing here right now is 2.8 times 1, right? 1, 2.8, and then this is times 1. So this is 2.8 long and 1 wide. But we didn't want 1, we wanted 0.8. So let's change this to 0.8. We'll erase that bottom. So if we wanted 2.8 times 0.8, we could now start figuring out how much we have. And we can say that's like 1 and 2, and then what is this? 0.8, I think, because that's another, oh no, 8 rows of 8, 0.64, that'd be 2.64. But we don't want that. We want to divide 2.8 into 8, like that. When we divide 2.8 into 8, well, let's take a look here. This is very similar to what we have here, except we had 2.8 into 8s. And so what they did is they actually took these blocks took a complete 2.8, and they started dividing them up. So I'm going to show you that on camera with base 10. They took 2.8 and they divided them into 0.8s. So let's pause and I'll show you that in blocks.
Pause it?
Yeah.
Okay. Oh.
Ready, cameraman?
Yep. Good? Yeah. Good.
All right, welcome back. We have base 10 blocks. What I've done is 2.8. What we want to do, we want to take 2.8 and we want to divide them into 0.8s. Now I can go 1, 2, 3, 4, 5, 6, 7, 8 right here. There's a grouping of 8. But I can't break these up. So we're going to pause the video. I'm going to trade these in for tenths.
Oh.
All right, welcome back. We now have traded in, we had 1, 2.8, but we traded these ones in for tenths because we want to see how many completes we get. So 2 decimal 8 divided into groups of 0.8. So I've got a group of 0.8 here. So that's one group of 0.8. I've got 2 groups of 0.8. I've got 3 groups of 0.8. And then a few more. And then a few more. So we want to start thinking, how much did we get? We had 2.8. We divided them into groups of 0.8. What did we end up with? Please pause the video and we will compare on our boards.
Okay.
All right, welcome back. So we took a look at it, and we had 28 tenths. Or 2 decimal 8s, 2 wholes and 8 tenths. And then it said we were dividing them into 0.8. And what we found is that we ended up with 3 total groups of 0.8 and 4 out of 8. And a lot of you were able to say, wait, that is 3 decimal 5. But let's take a look at another way you can do that. I'm going to show you what they did here in the textbook. They had the same number, but they rearranged them. And let's rearrange ours like that. It said we had 1, 2, but we're back. So let's just review quickly how the textbook arranged. They had 3 total and then a few more. And what they did is they realized they couldn't fit those tenths in there like this. So they broke a piece off and started scattering them in there. And what we quickly found was that we had, once we broke those tenths up, we then had 5 rows of 8. But of course that is equal to 40, which still gives us 1, 2, 3.5. Or what they found in the textbook is they got 1, 2, 3 complete and said what was left. The question had said, how many can you get and what is left? What is left is 0.4. But there's another way that we could have done this, and that's just with numbers. So let's take a look at what that looks like. And can I ask my grade 8s to be quiet while we do this, as it is your silent reading time. All right, let's take a look at the symbolic method for doing this. I have 2.8. And Mr. Cameraman, can you make sure that I'm on the camera? Divided by 8. Now, the classic way that we can do this is long division. But I don't want to do this yet. Let's just do classic long division. I got 28 divided by 8. Is this possible so far? Okay. Now, a quick review of long division. How many times does 8 go into 28? Call it out. 3. Well, 3 times 8 is 24. I want to find out what I have left. I have 4 left. Now we got how many 8s and 4? Oh boy, we got a bit of a problem, don't we? Well, this is where we'd have to go into the decimals. So let's do a decimal. Drop it down. 40. How many times does 8 go into 40? 5 times. You've got it. 5 times. 5 times 8. That's 40. We now have no remainders left. So is my answer 35? Does 8 go into 28 35 times? That's probably about 3, right? Because I mean, I know 8 goes into 24. So my estimate would tell me it's probably going to be around there at 3.5. Well, if we can do this, let's change it to what the question actually says. Let's go 2.8 divided by 0.8. Divided by 0.8. Now let's pause and see if we can take this down. Camera person, please pause. All right, welcome back. Wobbling camera, if you can just steady that. Welcome back. So what we discovered as we were working on it, it got confusing right off because if I were to go 0.8 into 2, well, I can fit 2 0.8s into 2 holes. And then 2 times 0.8 is 1.6. Like that, and then drop the 8s. Wait, doesn't that get complicated? Like at that point, I'm like, I don't know where to go. So you know what I'm going to do to make this simple? I'm going to pretend there's no decimals, just like we did before. Oh, and then I put a decimal. And we did this before. We said it goes into 28 3 times, and that's 24, and that gives us a remainder of 4. And then we dropped down a 0 with the decimal, and we found that went in 5 times, just like before. Now we can just figure out where to put that decimal. If I estimate, remember when we front-end estimated? What's 3 divided by 1? 3, okay. So should I put the decimal here, here, or here? Right in the middle. Because if my estimate is 3, it's probably not 35, and it's probably not 0.35. But it's much easier. You just have to remove the decimals, estimate, and then place the decimal. So your 3 steps. Remove the decimal, estimate, and then replace the decimal. Now we'll look at a quick example in the textbook, but I'm not going to actually do it because it's all written out for you right here. Divide 52.1 divided by 9. Well, as you can see, they got rid of the decimals right off because they knew you were going to hit insane confusion. So they started off. And they went down the line and they started adding zeros wherever they needed until they got almost to the end. But their answer that they got here was that 52 divided by 1 equals 0.9, or divided by 0.9. They said it equals 5,788. Let's estimate quick. We remove the decimals. Step 1. Let's estimate. What's 52 divided by 1?
52 divided.
How many 1s in 52?
52.
52. So where should I put my decimal, you think? What's the closest to 52? 57.88. So we removed the decimal. We did the long division. We estimated our answer. Now we just have to replace that decimal. It's 57.88. Did we get there? For sure, 57.88. And we got it. Now, some of you will like doing this. Some of you will enjoy doing this. How many of you right now are like, yeah, I'm down with this? All right. Now there's a trick though. Long division has many steps. Here is the big problem with algorithmic math. If you make one tiny mistake, it's all wrong, right? How many of you got a quiz back and you just did one tiny little mistake and it's totally wrong now? Absolutely. But when you estimate, you're going to realize if you've made an error because your number will be wackadoo out of line. Always estimate at the end of your question and ask yourself, is this a reasonable answer? If you ask yourself that and you come to, oh my gosh, that is completely unreasonable, start checking all your steps. You'll probably find that you made one minor mistake. Or if you're correcting in the back of the text and you go, what? Why did I get that wrong? I swear I got it right. It was probably one minor error. I hope this video helps, and I expect lots of questions this week for your quiz on Friday. Thank you, camera guy. You can pause the video.